guys. I'm so glad you're doing summer math with me this year, and just want to get you guys super ready for Algebra 2. The thing is, with geometry, you're out of the game for a little while. I mean, you're solving equations, but you don't remember some of the function type stuff that came out of Algebra 1. It's been over a year. So today we have to review that before we can take off from there. Algebra 2 is the year of graphing. Pretty much all year, that's the common theme. And I want to make sure that you see a lot of it. So let's start with Lesson 1. Remember, as you're going through this, if it's easy for you, then just kick back and watch and maybe take a few notes if you need to write it down. If it's something that you're weak at, you may have to pause and rewind and make sure that you get everything you need out of this video. So do the best you can, and then you can try the practice problems after these notes. Okay? So today we're going to talk about linear functions, and of course, linear function just means, a line, anything with a slope that's consistent and that looks like a line. Now the parent, there's a specific parent function, and I'm going to write it as f of x instead of y equals. So a function evaluated at x is equal to x. That is the parent function. There could be a change of slope. There could be another number plus or minus back here, but this is the parent function, and what it looks like is a diagonal line. This is something you may remember this. Let me change colors here. It goes straight through at a diagonal, and it has a slope of 1. You start at 0, over 1, up 1, over 1, up 1, and that's how you make that line. This parent function has a domain and range of all real numbers. And I write all real numbers as like a super capital R. You could actually write all real numbers, or you may have a teacher this year that starts talking to you about something called interval notation. Interval notation just means that you use parentheses, and it looks like a coordinate, but it's definitely not a coordinate. You talk about on the left how far out it's going to go, and to the left it's going to go to negative infinity, and then as you keep going to the right, this thing is going up to positive infinity. So that is interval notation. This also means all real numbers. So these three things mean the same thing. Okay, so you'll see that especially in a pre-AP classroom. All right, slope-intercept form is what most people are used to. Y equals mx plus b, where m is your slope and b is your y-intercept, okay? And point slope form is one that you may not have used as much, but if you plan on taking calculus later on down the line, this is a really good one to know. Y minus y1 equals m times x minus x1. This form is awesome if you are given a point and you're given the slope. So if you're given these two things, use this form. You will be plugging in your point here and here for the x and the y, and you'll be plugging in your slope. And so you plug into these three, and then you're able to have your equation. And then the slope formula, it's the change of y's over the change of x's. That triangle is called a delta. So delta means change of. And remember, slope is a rate of change. You might have also seen rise over run, so some of this should be familiar from back in the day, but if not, that's okay. That's why we're doing it. And the formula a lot of people see is y2 minus y1 over x2 minus x1. So all of this is a review of what you did, hopefully some of what you did back in the day in Algebra 1. So we're going to work on actually using these and applying it to real problems, okay? So let's go down to our next section, which is graphing. So to graph, I highly recommend that if we're going to be graphing, we always want to be in slope-intercept form. Y equals mx plus b, because then you can see with your own eyeballs, this is my slope, whatever number's with x, and the number that's added or subtracted, that is my y-intercept. So in a problem like this, it's real easy to see that this is your slope, and this is where we're going to start, is at a positive 1, okay? Now, slope is usually written as a fraction, and if it's a whole number, you can easily make it a fraction by just sticking that whole number over 1. And now we're gonna graph. So I always start with my y-intercept, and a y-intercept just means where am I crossing the y-axis. So at 1, I'm going to go ahead and put a coordinate at 1 because that's my y-intercept, and then I'm going to do the slope of -3, 1. And since it's y's over run or y's over x's, this negative is telling me to go down 3 and then over 1. And I say over 1, but I always usually move to the right. So down 3, 1, 2, 3, and over 1. And that's where I will put my next coordinate, and then that is where I will play connect the dots. And that is graphing 101. Okay, graphing again. So what makes this one different than the one that we just did? Well, you may notice it's not in y equals mx plus b form. It's in something called standard form, which nothing's wrong with standard form. It's just harder to graph in. So my advice would be first to isolate the y and to get that y by itself, which just means do your algebra that you know about moving things around the equal sign and get it isolated. So my first step, let me recopy it so I can work with it. My first step would be to subtract 2x from both sides. And you can't put these two numbers together because one of them has an x and one of them doesn't, so I just recopied it. Now you want the y to be by itself, just like it is up here in slope-intercept form. So we need to divide everybody by -5. Okay, and when we do that, we get y equals, okay, a -2 over a -5 is 2/5 x, and then a 10 over a -5 is a -2. So that would be how you need to rewrite it, and then you can graph it, okay? So we're going to have to squeeze this graph in. It's kind of a tight fit, but we can do it. All right, so how do we do it? Well, we start at the y-intercept, so go to -2. And put a coordinate, and then we count the slope. So it's a 2 over 5, which means it's up 2 and right 5. Now why is it up instead of down? Well, that's a +2. So positive tells you to go up, negative tells you to go down, just like in the last one. So up 2 and then over 1, 2, 3, 4, 5. And put another point there, play connect the dots, and voila. Okay, and just one, it says one more just for fun. If you're given 2 points, this is like the thank you teacher, I know you like me. This is one of those problems because you don't really have to think a whole lot other than do I remember how to graph a point, right? If it's the point 3, 0, that's over 3 on the x and up 0. And this point of 0, -1 would be down here, and then you can just play connect the dots. So why would I have given you something so easy? Well, sometimes this is worded a little different, like because that's the x-intercept and because that is the y-intercept, instead of giving you the actual points, it may have actually said x-intercept 3, y-intercept -1. And so if it gives you in either form, it's good to know how to handle that, okay? So that's it. You're just graphing from there. We're not even writing the equations today. All right, so what's next? Next is solving linear equations. This you did a lot of in geometry. I know you did. I know you've done a lot of this, but we still need to practice this stuff because, oh my gosh, it never goes away. Never. Even when you make it to calculus, even when you make it to college, you will be doing this until you're like 21 and done with life and ready to move on out of the education world, okay? So we got to be good at this. Let me change colors. Let's do whatever that is. Great. Okay, so I like to move all my variables to the left side. And then I like to move my constants over to the right. So I'm going to do this in 2 steps. I'm just going to recopy. Of course, that makes a 0. And once I subtract the 5x from both sides, now my x's are on the left. And I want to move this -3 over to the other side. So remember, that means you do the opposite operation to move it across. So now I need to add 3 to both sides. So negative x equals negative 7. And then you don't want to leave a negative on the x. You're going to divide both sides by negative 1 is what I did there. Divide by negative 1, divide by negative 1, and you'll get your x is 7. So hopefully that's really familiar from geometry and algebra 1. Here, this is almost the same exact problem, except there is an added step of distributing. And be careful distributing. Make sure you take that negative 2 and you multiply it by both the x and a negative 2 times that 1. Now it looks just like this problem on the left. And like I told you a second ago, I like to move my x's to this side. So since that was a minus 2x, I'm going to add 2x to both sides. I'm going to recopy what I have here. That's now a 0. Bring down the negative 2. And now to isolate this x, I need to get rid of this 3 in the front. So let me add it to both sides because I'm doing the opposite. That's now a 0. Bring down the 6x. And then a negative 2 plus 3 is just a 1. And now to get the 6 off the x, I'm going to divide it off. So x is equal to 1/6. Okay, what about something like this? I know it's fractions and we all hate fractions, but you know, they don't go away either. We've got to be able to handle them, okay? So I'm going to recopy this 1/2, and I do want to start by distributing. So a 1/3 times a 3 is just a 1p, and you can write 1p or you can just write the p. And then a 1/3 times a negative 1 is minus a 1/3. And then we'll recopy this. Okay, now I'm going to bring this p to the other side, so I need to add it to bring it across. And I'm going to go ahead and put these fractions together. So I've got a 1/2 minus a 1/3. Now, if you don't remember fraction math, come down here and rewrite it. We're doing 1/2 minus 1/3. You need a common denominator. So it's going to be 6. And to turn this 2 into a 6, I multiplied by 3, so I need to multiply the top by 3. To turn this 3 into a 6, I multiplied by 2, so I need to multiply the top by 2. And then you just do numerator math. 3 minus 2 is 1. Recopy the denominator. So this all just turned into a 2p right here, and then plus 1/6 from my answer down here, and that is all equal to 4/5. Okay, now I'm going to subtract the 1/6 from both sides, and once again I'm going to come down here and math it out. I've got 4/5 minus 1/6, so the common denominator would be 30. Alright, I'm multiplying this by 6 to get 30. And so that becomes a 24. I'm multiplying this 6 by 5, so that becomes a 5. 24 minus 5 is 19/30. This is a really pretty problem. Not? Okay, 19/30. Cool. Now, the 2 is stuck on the p, so I need to divide both sides by 2. Now, when you are dividing a fraction by 2, okay, dividing by a number is the same thing as multiplying by the reciprocal. So if you write it as 19/30/2, that might really confuse you, right? It's like a 3-part fraction. But if you think of it as, oh, I just multiplied by 1/2, then on this side, you're just multiplying by 1/2, and you're just going to get 9/60. And I think that reduces to like 3/20. So that would be the answer there. Okay, so not a lot of new stuff, but it might be a pain to try to remember all that. But now you've got some practice problems you're going to get to go through and try to do a little graphing, try to do a little solving, and then we will work on equation writing next time.